Hi everyone, welcome to RS Virtual, the journey toward flexible plastic packaging recovery. I am Melissa Radiwon, Director of Marketing for RS, and I will be your host today. I would like to share a few housekeeping notes. All attendees are muted. However, we do invite you to submit questions using the Q&A panel. Simply click on the button at the bottom of your screen to open the Q&A panel and type in your questions anytime during the webinar. We'll try to get to as many as possible. Finally, we are recording this webinar. We will post that recording to the RS YouTube channel and share the link with all registrants early next week. We want to get you involved in our meeting today, so we've included several polls throughout, and it's easy to participate. You either use your mobile phone or you can open up another window in your web browser. So let's walk through the phone. If you're gonna use your phone, you open up a new text message and you type the message recycle123, no spaces, put it all together, recycle123, and send it to the phone number 37607. That text is gonna connect you to the polling system. You'll get a confirmation message back. When I put a poll up on the screen, then you simply text your answer back to that same number and your response is going to be tallied. The other option is that you can open up another window, don't close us, open up another window on your computer and you type in the URL pollev.com/recycle123. That way you're going to be connected to the polling system and you'll see the poll appear as I put it up on our screen here. And you simply use that window to submit your response. So hopefully everybody has made those connections, either text or via the browser, because we're going to try it out right now. Somebody's already in there. You guys are awesome. All right, so the first poll is to get a better understanding about the collaborative initiative, what you know about the pilot, or heck, that's the reason I'm here. I don't know about either one of those. So it looks like we have quite a number of you that are familiar with both. Oh, but look what just took the lead. It looks like there's about a third of you that are here to get to know it all. So that is great and excellent job at this polling thing. So you guys are going to be set to go when we have the next one coming up soon. Let me walk you through today's agenda. First up is Brent. He will provide the brand perspective and talk about the importance of flexible plastic packaging, its use, and its recovery. Next, Susan will give us some background on the materials recovery for the future organization, as well as flexible plastic packaging. JP Mascaro will follow and discuss why it's important for his material recovery facility, his Murph, to be part of the pilot research. Next, Beth will dive into that research and those results that came out of the pilot. And Anne will give us some clues on what an R-Flex bale is and who uses it. And then we're going to save a little bit of time at the end for some questions. So don't forget, Q&A panel, start submitting those questions. But let's get rolling. First, I'm happy to introduce Brent Heist. Brent is the Director of Global Packaging Sustainability at Procter & Gamble. In his 27 years at P&G, Brent has worked in process development, products research, and most recently packaging development across several business units. Brent is located in Cincinnati. He holds a Bachelor of Science in Chemical Engineering from the University of Houston and an MBA from Xavier University. Brent, thanks for chatting with us today.
Thank you, Melissa. Happy to be here. So happy to share brand perspective on why flexible packaging is used and why we're so interested in the recovery of that material. So the starting point for any packaging design is that that packaging absolutely must protect the product through the distribution, sale, and use of the product to protect the consumer. And we know that flexible plastic packaging does a great job of doing this. It's a great technical solution. It also provides some additional benefits to visibility of the product, which is really important in the food industry. As well, flexible packaging can also provide a lot of convenience for the consumer. We see that a lot in the resealable packaging as well. You see that both in food and non-food products, giving you the storage flexibility. So on the next slide, we share a little bit though about what it means to brands for the recovery. So all of the major consumer goods companies have goals that 100% of their packaging will be recyclable. This requires that the supply chain be in place to collect, sort, and process those materials back into useful materials for additional products. There's a pretty good collection system in place in store take-back programs. You can see that upper picture there being one of those, but those just aren't scalable to the need. So we really do need to be able to ensure that we can collect this material curbside and sort it in a Murph without the issues that you see in that other picture, which is the typical wrapping of the flexible packaging around the equipment in a Murph. We also need to ensure that there's viable end markets for the material, and the brand owners themselves want this material back as PCR because many of them have goals as well to be using PCR in their flexible packaging. And that's why so many brands, suppliers, and converters are involved in this material recovery for the future project. On the next slide, you'll see some of the reasons or the commitment that we've had to this effort. So you see the brands in the upper right-hand corner, as well as the suppliers and converters of this material. So material recovery for the future was initiated by this group to bring together these key participants across the industry to prove that this flexible plastic packaging could be collected curbside, could be sorted in a Murph without all of the issues that we know. And it really has done that. It's proven that this flexible plastic packaging is not the poison to a Murph that we've all heard about, that it can be sorted. And the pilot was very successful in that regard. So now, for the rest of the presentation, you'll hear more about how that was done and the sellable bales that have resulted from that effort.
Thank you, Brent. That was a great introduction. Next up is Susan Graff. Susan is a principal and vice president at RRS. She co-leads the Global Corporate Sustainability Service sector. For over 30 years, she has provided individual and collaborative sustainability and materials management solutions to both industrial and government clients. She led the development of the Sustainability Scorecard. It's an RS analytic tool used by manufacturers to reimagine business strategy, metrics, and employee training, all in the name of achieving better sustainability profiles. Susan leads research and recovery value chain facilitation projects for a number of consumer brands and foundation client partners, like Materials Recovery for the Future. Prior to RRS, Susan founded ERS Global, a sustainability consultancy that served Fortune 200 clients, and began her career at the US EPA, serving in several senior roles at the Atlanta Southeast Regional and Headquarters Office. Susan, welcome to the webinar.
Thank you, Melissa, and good morning, everyone. I am really excited at the chance to share this research with you today. We have a great diverse group of attendees, so I look forward to some important dialogue. But I wanted to give you just a few overview comments about materials recovery for the future, how unique it is in terms of how it came together with members of the plastic packaging recovery value chain who were seriously aligned and committed to understanding a way to most feasibly capture the value from this material. We all know, there's a lot of professionals on the line today. We all know you can recycle or you can sort anything if somebody's going to pay for you to get that material back. We know that recycling is an economically driven system in the US in particular. where, you know, compliance does not dictate recycling as it does in other regions of the world. And so the group of brand owners and partners from the recycling industry who came together on this project really were well aligned on the fact that they wanted to have a restorative impact on communities in the industry, and that meant that everybody along the supply chain that was going to be developed here needed to make money. And I will be the first to tell you, as the research director for this effort, that we're not there yet. We are still immersed in the fine knitting of developing this supply chain. But the proof points have consistently come in to prove the significant research questions that were posed from the beginning. Can this be economically sorted? Can it be used as a mixed bale? This is really the first mixed bale that the U.S. Murph fleet would be dealing with in a large, impactful way. 12 billion pounds of this material generated annually. So the promise of this research, I think, still holds strong. We still have a lot of work to do, but today we want to share with you the major proof points that have been established, and also share with you where we're still, working on some of the challenges with commitment to the environmental impacts being a net positive or restorative impact throughout the entire life cycle of the new products, from the virgin product to the new product, as you compare it to other product packaging choices. This packaging was invented because there was a need to use less plastic. And so we want to keep true to that mission, keeping those molecules in play in product after product use. So if we go to the next slide, I want to just make sure we're clear from the get-go, because we get this question a lot. Just what is flexible plastic packaging? Because it is a very broad category, a very popular category today. And it includes all of these formats you see on the screen. So we did really want to look at them as a group for recycling. Why? Because we know what drives end markets is a consistent, large supply of a substitute feedstock for virgin materials. And together, like I said, this constitutes 12 billion pounds a year. Together, it's majority, which Ann will get into later, made up of polyolefin plastics. And we know that in other regions of the world where there are compliance systems to ensure this material is recycled, that it is used to make a variety of different building products. And it can be further sorted in order to make plastic products through the intermediary processing that may occur before reclaimers or by reclaimers prior to manufacturing. So I'm going to turn it back to you, to Melissa, so we can dive right in and hear from JP.
Wonderful. Thank you, Susan. That was a great setting of the stage for us to continue forward. Now I'd like to welcome Joseph Moscaro Sr., JP as we know him. He is a third-generation member of his family's company, JP Mascaro and Sons. He is the Director of Recycling and Sustainability and oversees their Murph in Birdsboro while directing their Total Recycle entity. JP, it's all yours.
Thank you, Melissa. It's a pleasure to speak to you all about my journey here with material recovery for the future. We opened up our first facility just 4 years ago in 2016. It's our first Murph, and when we opened it, we thought it would be really important to have the best equipment and we really wanted to do a first-class job, so we really created a first-class facility in Birdsboro in every way that we knew how, from a presentation point and from an equipment point. But very early on, I was actually the general manager of the facility, and I noticed that I had two screens, a Lubo 440, which had an 18-inch shafts anti-wrap system, and I had a Lubo 330. And the 330 looked like this picture right here in front of us after about an hour of working. And it took us a heck of a time to get this stuff off of our screens. We'd put 4 guys in there, and we'd spend, you know, an hour in there trying to remove it all, and we still couldn't get it all. And we noticed that the anti-wrap screen didn't have anything like it. We could actually do the job in 15 minutes. So very quickly we made the decision that we were going to remove this screen and we were going to put a second anti-wrap screen in. Could you go to the next slide? Next slide, please. Yep. So like I said, I'm a 3rd generation member of my company, and we're all strategically placed throughout it. And, you know, being the recycling head of the company, I was looking for solutions for this film. And when I found out about the MRFF initiative, I was very excited because it was very inclusive. We weren't talking about just taking out the retail bags or the shrink film. We were talking about all kinds of different stuff, chip bags, candy pouches, dog food bags, all kinds of stuff that typically we wouldn't recover. And we were talking about doing it in a way that was quite unique. Typically, when we were searching out other facilities, we saw that they had the airflow systems and they were sorting it out manually. And we didn't think that was an effective way to go about it, but using the system that we've designed here, and you can go to the next screen, we found that we can recover a lot more material. What we did is we put an optic over each of our paper screens, our 2 newspaper screens and our mixed paper screen. And the optic does the job of 20 men and makes decisions in a millionth of a second. And after we have those 3 optics, which actually remove the film from the paper, we then remove the paper from the film with a 4th optic. We then put in a paper magnet that removes the 3D objects. And then after the paper magnet and after the 4th optical, we have a hand sort on the paper that the 4th optical sorted, and we have an opportunity to recover anything we can out of the R-Flex. So we put in a quite robust system that has many advantages. You go to the next screen. We were able to sort this material out and find that we could gather most of it through this means. And every day we work on perfecting the system. But then the next step of this was rolling it out to our communities, which was a really exciting part of it. The consortium thought it was really important that we had a couple prerequisites, and we thought so as well. One of them was that we use toters for this. That being that we're with a lightweight material, we didn't want to put it in the typical recycle bin and worry about things blowing around in the wind. So you had to have a toter. For us, we needed to collect and process your material. If we just processed it, we didn't want to have to rely on another hauler. You know, we didn't know how they would feel about it. So it was important that we collect and process the material. We rolled it out to 12 communities. We put stickers on their cans. We sent out a flyer to everybody, and we put advertisements on their website that you can see right here on this slide. We also put out a hotline. So anybody who had any questions at all could call, and we have this phone number was strictly designated for any R-Flex questions. And we got a great deal of them, but we also got a great deal of responses where people were really excited about the program and really happy to hear that, you know, we had this availability to recycle these, or at least collect these products that nobody else was collecting, and that their community could be part of such an exciting program. We're really proud to be part of this program. We think it's really exciting to have 3 industries working together, the packaging industry, the equipment manufacturing industry, and then of course ourselves, the solid waste and recycling community. You know, it's really neat to be working together towards the same goal and coming together and putting our minds together to try to figure out how to collect this stuff. And we plan to continue with it. If we have any other future installations, this is going to be considered. We've learned from this what works and what doesn't work. And the next systems, we're really excited for the opportunity to see if we'll be able to do even better than we're doing with the system during a retrofit. You can go to the next slide. So this is just a synopsis pretty much of what I've said already. Like I said, we're very proud of it. I forgot about that last slide, so I'm pretty much able to wrap it up right now. I know I've gone over my time already.
Oh, you're good, JP. Thank you so much. It's you know, great to get some detail on how the installation went with the various equipment and the community involvement. So appreciate that that explanation there. All right, folks, you got the sneak peek on the poll on that one, but we have poll number 2. Now that we've talked about flexible plastic packaging, how are you dealing with it in your organization? And we have a couple of options here, updating Murph equipment, ramping up education, joining some sort of partnership or investing funding to recycle it, or you're not taking any action at all, or there's something else out there that you're doing that we didn't capture in our multiple choice just yet. And let's see, it looks like we have, oh, you guys are changing. This is great. So it looks like we're ramping up education to keep flexible plastics out of the MRF, also joining partnerships or investing funding to recycle it. And then there's some other activities going on or not really taking any action at this point. So that gives us a good idea of how things are, what's going on out in the marketplace there. So thank you for providing your insight on that. Now it's time to hear about those results from the pilot. So Beth Coddington is a consultant with RRS. She has more than 15 years of experience in data management, models, projections, financial analysis. She works with clients to develop actionable metrics for their projects and tracks program outcomes over time. Her work includes data collection through survey and other research methods, management of large databases, qualitative and quantitative data analysis to evaluate and project the performance of recycling programs. Before joining the staff at RRS, Beth worked in the nonprofit sector, focusing on low-income housing, including both direct service provision and research-driven advocacy. Also, we're very proud of Beth, and we want to mention that she is a Waste 360 40 Under 40 award recipient. So Beth, let's hear about those results.
Thanks, Melissa. So I'll speak about the research results from our pilot that we did over the past 2 years. But before going into those, I want to mention that this is really the latest phase in a research program that goes all the way back to 2015. And we have years of research accumulated at this point. If you're interested in learning more about our foundational work that really laid the groundwork for this pilot, it's all available on our website at materialsrecoveryforthefuture.com. So this pilot, we kicked it off really in January 2019 with the equipment installation, and our report was released in June of this year, so representing a year and a half of really intensive work. If we go to the next slide, we'll look at how we established the goals and how we measured our progress against the goals of the pilot. What we're trying to learn through this pilot is it technically feasible to sort this material, the flexible plastic packaging, from our curbside single stream? So we established 5 goals that would measure how well the equipment was performing. And it's really 4 quantitative goals, and then the 5th one is just integration of our controls with the existing Murph, so it all works together. So taking these one at a time, our first goal is about capturing the flexible plastic packaging from our inbound feedstock. We wanted to try to capture 90% of the flexible plastic packaging, if that was possible. We measured this through RFID testing, and that's where we add an RFID tag to a wide variety of samples of packaging. We feed it into the Murph, and then we use RFID readers that can track where that package went in the Murph, and then we can see how much of the FPP that we're entering into the Murph actually ends up in that bale where it's trying to go. So by the end of the pilot, we measured this at the beginning, middle, and end of the pilot. By the end of the pilot, we were capturing almost 3/4 of the FPP, but not quite at that 90% benchmark that we had set based on laboratory testing. So that's still an area where we're working on improving the capture into the RFlex bale. The second goal relates to the quality of our RFlex product. We're trying to make a bale of RFlex that is primarily flexible plastic packaging, and only 15% or less of it would be paper that's sort of collected collaterally. We measure that by taking the RFlex bale, breaking it open, taking a sample, and weighing out how much is RFlex. And that goal was a big success. By the end of the pilot, we were consistently getting lower than our 15% goal of paper in that material. Our third goal relates to improving the quality of our paper stream, and JP already talked about how the opticals really replace a lot of the very labor-intensive quality control work on those paper products. So we measured before the pilot and after the pilot to see if the quality of the paper products improved, and we were successful in that with the newsprint bale going from a 5.1 to a 1.3% contamination rate, and the mixed paper bale going from a 5.7 to a 1.4% contamination rate. And we also got qualitative feedback from the buyers at JP's facility that they're very happy with the cleanliness of the paper products that were coming out of the new system. Then the fourth goal here is the labor requirement. And we're trying to, even though we're making a new bale and adding a new kind of material stream into our inbound, we're trying to reduce the requirement of people needed to quality control the fiber products. And that was also a success. At the end of the pilot, the total FTE requirement for that staffing was 38% less than it had been before the pilot. We've recently added a quality control person at the very end before the RFlex goes into the bunker. And so since the pilot was over, that number has changed a little bit, but still a reduction in labor overall. And now, if you go to the next slide, I just want to talk about the progress over time with this pilot. This slide shows us some of the progress on the purity of the RFlex bale from the fall of last year up to the present. And if we actually went back all the way to the start of the pilot, January, February, March, when we had just installed the equipment, we were producing bales of RFlex that were actually less than half flexible plastic packaging. So we're really getting a lot of collateral paper, and you can see this if you look at some of the data that's in our research report. As we got into the fall, we started to get really close to our benchmark where the bale is much more plastic than paper. And then you can see at the end of the pilot, we're consistently under 15% paper with our new equipment upgrade, and this is since the publication of our report, so this is kind of new information. We're actually almost 90% plastic in that bale, and less than 15% contamination overall, only 10% fiber, and then 3% that's flattened containers and other trash that gets into the stream. But really a very pure bale of plastic and a huge testament to the work that's been done at the Murph to make this program a success. So this is, like I said, you know, this is our latest stage in the journey of this research. It's not the beginning of it, and it's not the end. They're continuing to do this analysis to track the progress of the bale, and if you're interested in following the ongoing progress of this research, there's actually more work in the pipeline that's scheduled to be published. So I'd encourage you all to follow the project. We have Twitter and LinkedIn, and you can check on the website materialsrecoveryforthefuture.com.
Wonderful. Thank you, Beth. Appreciate the detail with the results there. Our final panelist is Ann Johnson. She is a principal and vice president at RRS and co-leads the Global Corporate Sustainability Service Sector with Susan. She has more than 20 years of multidisciplinary experience working with global consumer product brands and manufacturers on sustainable product and packaging, design and recovery, as well as corporate sustainability strategy and goal setting. She also works on international solid waste and recycling issues, particularly in Europe and South America. Anne was key in developing RRS TrueCycle, an assessment that analyzes product packaging recyclability and compostability. Her previous positions as director of the Sustainable Packaging Coalition, a consultant at McDonough-Brunner Design Chemistry, and subcontractor for the US EPA have added to her expertise in life cycle thinking, packaging and waste management systems, and sustainability materials management. Anne is going to help us better understand RFlex and its potential end markets. So Anne, go ahead and take it away. Anne, I believe you're muted if you want to unmute yourself.
Can you hear me now?
We can hear you now, thank you.
Okay, great. Good. So can you go to the next slide, Melissa? So as we started this project, there was a lot of intention to understand, could we sort this material? What was it going to look like? We did a lot of research as both Susan and Beth have gone through. And as we started to realize we were going to be able to successfully sort this, we started then to ask questions, where was it going to go? Because it doesn't do us any good if we can't find end markets that can manage and make this RFlex into a new product. So we spent a number of years looking at who currently was able to process Murph films or mixed plastic films, and there's been a number of I would say organizations that are also studying this. C-Flex was also doing this at the same time, so we've had some communication with them about this. So we have worked very systematically to identify potential end markets, and one of the really exciting things that's come up from this is the innovation that's being developed as people start to understand what is possible with this material. We found the most advanced opportunities in Europe, and then what we're seeing is that some of these types of technologies are now, particularly post-national sword, being brought to the US. So we started with sort of a theoretical bale composition, which some of the metrics that Beth went through are really built around it. We knew we needed to have a bale that was, significantly plastic rich. We had to have, a minimal amount of paper in it. And what we found through the pilot is some of it was unexpected. We did not expect to find containers in our material, but we did. And so as you saw over the sort of course of our testing and bale breaking and auditing, there's been a huge amount of effort to optimize this bale so that it's very polyolefin rich. We're minimizing the amount of fiber. I think this particular pie chart I don't think is reflective of the very latest data, but we're now around about 10% fiber, which is really outstanding. We're very close to 85% plastic, much of that olefins, and then our sort of remaining optimization opportunity is really, really reducing this other category, which has containers and residue. So if we can, in the new quality sort station that's gone in, address that container piece, we're going to have a very nice bale. So maybe we can go to the next slide. So we've systematically been testing this material. We had to wait until we had a representative bale. Melissa, can you shift to the next slide for me? And we didn't want to have people testing something that wasn't going to be realistic. So now we have a representative bale. And what we've done is reached out to different end markets that were interested in being able to test this. Sometimes the tests were, actually we had to conduct them in Europe because we didn't have the right technologies here. In other cases, we had companies that could take bales and do them on site. So there are two different sort of end market paths that we've explored. Because this is a mixed material bale, and when we say that we mean it's paper plus plastic, we really needed to identify those markets that could take both the paper and plastic and make a product out of it. And we have identified those, and actually it's a very efficient process. They like the olefin-rich nature of the bale, but they also really want the fiber. And this market is roof cover board. They make, you know, this is like the sheathing for roofs. And it ends up that this material makes a very weather-resistant roof cover board. And so this technology is commercially available. We're seeing it grow. And it's been around for some time in the U.S. So one of the other feedstocks often used in this type of material are cartons. So we have, RS has had quite a bit of experience with this. Then the other avenue we explored were really markets that were, in some cases, mixed material, durable products that took both a plastic feedstock as well as things perhaps like glass or other things to make what I call a mixed material product. And so pavers and rail ties are great examples of that. What we found is that they don't want the paper, so you either have to go through a dry wash or a wet wash process to get the plastic, and then it can go into these products. We had very successful testing along those lines, and we're still conducting one along with rail ties. But as you move sort of further to the right in this graphic, the requirement for really clean plastic increases as you move to the right of those green boxes. We've done testing with just making mixed plastic pellets that could then be used in a type of durable product. Pellets being the number one, but there are also a number of other things like crates and totes that are potential there. And then we just recently did a really exciting test with Charternext, who took pellets that had been wet washed and then extruded through an AREMA system, and they blew film. And we were all like, is this going to work or not? But it was really an interesting test. They got a really decent film. And so we've sort of looked at all these different types of end markets. We are still working on trying to do some tests with some chemical recycling end markets. Again, they're probably not going to want the fiber in there, but many of them actually have front-end pre-processing, so there may be an opportunity to remove the fiber at that point. But we've actually had a number of companies reach out to us because it's an attractive bale, potentially, because it is olefin-rich, and because there's such a high volume of this material, potentially. So let's go to the last slide. And this last slide just shows you we've developed a really close collaboration with a number of different converters and end markets. So that has really expanded our network so that we do represent the whole value recovery chain. Because, I mean, ultimately we need to find good end markets for this material. So you have some examples here of some of the roof cover board. On the bottom left is an example of the paver. These are commercially on the market. The company is located in Canada, and so this type of product has actually been in the market for some time in municipal applications for walkways and sidewalks. And then you have an example of the pellets that came out of the mixed plastic as well. So I think that you know, one of the exciting things for me, having been in this business for so long, is this project is a very intentional research and application initiative to look at how we can add what's been a very challenging material to recover, to figure out, can we get it into the system without causing disruption, and in fact bring it back into the remanufacturer value chain. And so as Susan said, we still have a lot of work to do, but I think we have some really promising results. So I will leave it there.
Thank you, Anne, and thank you to all the panelists who have provided us with, a full recovery value chain view of materials recovery for the future pilot and how we are really trying to recover this flexible plastic packaging. So now that we have heard from Anne and she explained what RFlex is and those end markets, what else would you like to learn about RFlex and those end markets? This is a short answer, open-ended question, so you just feel free to type in whatever, or did Anne do such a great job that we are all set at this point?
Of course she did.
She did, of course, of course. It looks like maybe, who are they? So maybe who are some of the end markets? What is the per ton value? What is the program for PP? What is RFlex? And while these questions are coming in, do you want to just take, reiterate what is RFlex? What is that name? How did we get that?
So RFlex is our acronym for our BALE, which is Recovered Film and Flexible Packaging. FPP is obviously a mouthful, so RFlex is the name we give our mixed material BALE. And somebody asked a question about PP. So our BALE does include polypropylene. So as you know, there are polypropylene dog food bags. It's used in a number of different film and flexible packaging applications. So there is definitely PP in our BALE along with polyethylene. So that's part of our sort of polyolefin mix.
Wonderful. And all of you are coming up with some great questions I don't think we're going to have enough time to hit them all. We have approximately 15 minutes left in the session. And so what I'm going to do is we'll collect these questions that are coming in on the survey, and we'll try to address some of those and have a follow-up email go out to all of the registrants here. So I appreciate all of you sending these in. We're going to go ahead and move forward with the roundtable portion. We're going to look at some of those questions you all submitted. And Anne, I'm going to come back to you since we're still talking about the packaging side of things. What have we learned about best practices in packaging design for recycling in terms of resin, sizes, shapes, structures, those sorts of things?
Right. So really connecting, where we see the most valuable end markets and then bringing that back into our BALE and then even back further into the components of our BALE, which is the packaging. We know that we would like to see polyolefin-rich packaging. And the more that it can be, a homogeneous resin, the better. We have learned that there are some colors that sort better than others. As people know, black is very problematic. So if you have a film package that has a lot of black, it's not going to sort that well. Size is really important. The system is viewing film plastics as two-dimensional forms, and that's why it flows into the paper line. So things that disrupt the two-dimensionality of it can end up being a challenge if they're too large. But if things are too small, they're not going to successfully move over our screen. So I think people are pretty familiar with very small packaging sizes. We'd like to see things that at least are 4 inches in one dimension to make it into the system. So I think that's what I'll leave with that.
Perfect. Thank you, Anne. JP, I'd like to bring you into this and ask, you were part of this pilot, your Murph, you volunteered your Murph in. So how does this system benefit the Murph, the materials recovery facility, outside of just making the RFlex bales?
Well, I think the most prominent advantage is the fact that we're cleaning our paper. You know, it's been very difficult in the last couple of years to have clean paper, and the requirements have gotten more stringent. Having opticals over each of our fiber lines is a pure advantage that we're happy to have. Like I said earlier, an optical does the work of 20 men. Essentially, we have 60 men on our paper lines cleaning fiber all day. So it's there's no higher advantage than that.
Perfect. Thank you, JP. We did get a question on, we hear about chemical recycling a lot these days. So is there a role for chemical recycling with this material?
Absolutely. I think that, this is a very attractive bale, as I mentioned, because of the composition and the potential volume. Chemical recycling technologies need really significant volumes and a reliable source. So I think this is definitely of interest. We've had a number of companies asking to test, not wanting to do that until we had a representative bale. So I think that is, the answer to that is absolutely.
Great. I'm going to jump to, well, Susan, could you talk to us a little bit about, we're talking about one Murph. This pilot was in one Murph. So expanding beyond the one Murph and the cost to implement this type of system, across the U.S.
Sure, because that's a great question. It's one thing to be able to prove a concept at one large hub and spoke Murph, but it's another to think about how could this kind of a system be scaled and what would it cost. And it's another question that we've gotten in the chat or in the Q&A is then who should be the ones paying that cost, and are we putting things on the backs of municipalities? I think what's important about MRFF, it's really, our charge was to produce evidence about what it would take, what it would cost. We know that this upgrade at JP's, and he was a full partner in this, was about $4 million all in, with a significant amount of that expense covered by the MRFF consortium. If we look at the fleet of other large Murphs in the US, it's challenging because there's, over 400 Murphs. They're all different. They all process different and accept different materials. But if we just take from that 400 and we say, well, let's focus on the other ones that are the large, high-speed Murphs. Why would you focus there? Because they serve the greatest number of households. They serve the majority of households in the US. So if you look at each one of those needing an upgrade, they cost anywhere from $3 to $5 million based on our technical Murph teams, evaluation of the equipment manufacturing industry. You're talking about $500 million pretty quickly to get them all up to snuff. Now, is that a lot of money? It's on par with the addition of other materials to single stream. We have a pro forma in Appendix B of the report for those who are interested in seeing what it would cost at the municipal level. It's about $2.40 to a year to add the material. I think that it's probably like an investment of the cost of one airport. That sum total $500 million in my mind relative to other infrastructure projects is not a huge number. It's feasible. It's where the issue is, where is this money going to come from? It definitely takes collaboration on the scale of public and private sector resources to come to bear here. Everybody's got to participate.
Thank you, Susan. And talking about participation, and what can companies do to make flexible plastic packaging more widely recyclable? So you're talking about finding it and collecting it, but what can companies do to make it more recyclable to start with?
probably work more together would be, I'll just start the conversation. I know there's others, but there is just so much variety, and every day some newfangled format comes out with different materials in it, different fitments, you know, getting smaller and smaller. I think there is a need to work together toward a more homogeneous set of packaging formats that reduce the variance in lookalikes being put in the system. A lot of the markets struggle with accepting new packaging formats because they're worried it looks like another format that has a totally different composition. And so I think the more we see conformance around the variety of packaging in terms of dimensionality and geometry, the more we're going to be able to work towards, you know, complete recovery of plastics.
You know, can I just kind of build a bit? There was a question around, you know, what role are the Murph sponsors playing in creating end markets? And I just wanted to respond to that because I didn't mention in my presentation that there's going to be a new part of APR's Demand Champions that's specifically focused on RFlex. And I think that kind of pull-through is really critical. We recognize that, and our sponsors are, in fact, doing that now. They are making commitments with some of the end markets that we've identified, and you know, RFlex is being used to create products that they in turn are going to put into their facilities. So you know, this is just the start, but we're trying to find all levers we can to help create this pull-through.
Great, thank you. And you know, talk about this being just the start. We have a few minutes left, and I wanted to get an idea from Brent and from Susan and anyone else on the panel. What's next? You know, we've gotten thus far. What's next, and where is the research taking us?
Yeah, so that's a great question. You know, and everything you've heard was what was done in this pilot to prove that this could be done technically. So we see a lot of efforts now in the continuation. You know, and I talked about the entire value chain. So the recycling partnership through their Flexible Film Coalition is picking this up as part of their efforts of collection and consumer engagement. So designing, you know, the right system for the right location to be able to recover these materials. The U.S. Plastic Pact, which was just announced recently, will certainly be a part of that effort as companies have committed to 100% recyclable packaging. We know that the Remade Institute is working on some end market development for this type of material. So again, completing that chain of collection, sorting, processing, and then end markets. And finally, just to mention another group, Alliance to End Plastic Waste, which has several corporate sponsors, is also engaged in what are the correct and applicable collection, sorting, and processing systems for this material. So we see a lot of efforts happening across the industry, hitting on each of those points in the supply chain that still have to be solved at scale across the rest of the country. So we've got the proof point. Now it's a matter of scaling.
Wonderful. Any other final thoughts from our panelists, either on, you know, more clarification on research points or future outlook?
Yeah, I just want to say this has been fantastic to get all these questions. We aren't going to have the time to answer them in 5 minutes, but Melissa, I think we should commit, especially our Murph equipment team, you know, is not on this call today. So I'd like to commit to be able to take this list and then respond one-to-one on the questions about the equipment and system configuration and our past research. I see several questions related to, you know, OCC screens and other pieces of equipment and impact. So let's make sure we take that as an action item.
Absolutely, yeah. We've had well over, I think we've had close to 300 people on the webinar today.
Yeah.
We've gotten quite a few questions, and obviously we can't get to them all. So yes, I will make sure that, put that on my to-do list. I will get those questions compiled, and we'll send them out to our panelists, and we'll gather those and then distribute them back to all of our attendees today. I want to take a moment to thank our panelists for providing great information on the pilot research. It's exciting to see so many people interested in this groundbreaking pilot, and exciting to hear about what's coming next. I am going to ask our attendees one more poll for you to respond, and this helps us to identify what other topics you want to hear from us for future webinars. This is another short answer question. So you just type in your, 3-4 words, whatever it is. The idea is that you want us to cover. And that will keep compiling as you guys are sending some in. Thank you to everyone that joined us today. Please make sure you check out materialsrecoveryforthefuture.com. That is where you can download the full report and dig into more of those details that some of you have been asking us about. As Beth said, there will be more reports coming out because the research does continue. Please look on the RS YouTube channel next week for the recording. We'll also be sure to send out a link. We ask you just to share it with your colleagues that you think would be interested. And I'm looking over at the poll, and it looks like we have EPR legislation, how to get a partnership going with your Murph. Ooh, I like that. Incentives for recycling, packaging waste versus food waste, consumer electronics, glass end markets. This is great information. This is really going to help us to build up our RS virtual series and get those topics in front of you that you really want to hear. So in the meantime, I wish everyone a great rest of their day. Stay healthy and stay safe.